Hello YouTube, RJ. Well, today we're going to be hacking a Simplisafe alarm system sensor, one of their newer versions, to add an external antenna. Now, why am I doing this? Well, my dad has one of these alarms, and he's got a garage. It's a detached garage. It's probably 50 feet from the house. He's had a Simplisafe alarm for years with no problem, the older version, but they upgraded him to a newer version here recently, and ever since we've put that in, the sensor out in the garage can't reach the base station. And he's, been telling me about his woes with this. And I said, I think I can do something for you. So this video is all going to be about what I did to help my dad out. Make sure you stay to the end of the video because there's a kind of a humorous story that goes along with this. Things maybe didn't go quite exactly the way I'd planned, but we'll get to that a little bit later. So let's jump into seeing what we can do about getting just a little more signal out of this sensor so it can make it to the house. Okay, so here we are on the bench. I've got the sensor here and I've got the little magnet. First thing we're going to do is we need to find out what frequencies it works on so we can calculate up our antenna length. That's if we find out we can get into this thing and we can find out that, we can get an antenna on there. But I'm expecting that's probably the case. So I'm going to go ahead and the first thing I'm going to do is got the spectrum analyzer fired up. I understand this thing somewhere between 400 and 500 megahertz where it operates. So let's see if we can find a spike on the spectrum analyzer somewhere in that frequency range. If not, we'll span it out. We'll find it. But I'm expecting it to be there. I believe they work like in the 433 megahertz band. So anyway, I'm scanning. I've got my spectrum analyzer set up like that. I've got the bandwidth turned down to 30 kilohertz to speed up the scan. And so we're going to go in here and I'm going to go set it up for let me do this first. The magnet there. And I'm going to set it up for a trace type at this point of max hold so it'll lock on the strongest signal it gets. I'm going to do peak, make sure it's on continuous peak. And now what we're going to do is I'm going to pull the magnet away and see if I find a peak somewhere. There we go. 433.83333 megahertz at minus 41.22 dBm. So I'm going to try that one more time. Let me clear it. Put this back. Go to max hold again. We're on peak. And we'll try one more time. Okay, 4.338333 megahertz at minus 42. So we're going to go with the frequency is 433.83, and we're going to go with it. We're seeing from my little tape spot. That's what the little square is for, so I can put this precisely back where it is. So my distance from the antenna and spectrum analyzer is precise. So we're going to go that we're looking for improving the signal better than minus 42.5 dBm. With that taken care of, that was pretty easy to find. We'll go ahead and I'll just leave that. In fact, what I can do is I can go back in and put it on type freeze, and I think it'll just hold that indefinitely like that. So here's what we're going to do. We're going to tear this thing apart now, or do our best to. So we'll be switching over to the microscope, working from there. So first what I'm going to do is slide the battery cover off, which is pretty straightforward, and get the battery out, which looks like that's just simply pulling this tab, getting your finger in there, I guess. Try pulling with my finger and put my microscope. There you go. Okay, obviously the positive is up, so we've got our battery out. And so let me look at this thing and see what we got. Looks to me like there are little tabs right here and here and here and here locked in. So I'm going to guess that we can get away with just getting this little screwdriver in, prying her out. I hope. Let's see if we can do it without breaking stuff. It might be difficult. Scratching up stuff, but man, you got it probably pretty good, but it does come. Okay. And over here, I would expect this to come easier now. It did. Now we need to pay attention to what we're doing. This piece here, the barcode is up and away from the barcode here, so that'll help me remember how to put it back together. So let's see, circuit board, anything holding the circuit board in. We've got a button over here. It looks like the button has got something that, let's see how that works. Hopefully that won't hold me up. And I don't see anything locking anything in. Let's see what happens if we just try to, maybe that plate holds it. Oh yeah, that plate just holds it in. So once you release that plate, there we go. Okay. Okay, there we go. So here's this. And a little button, if you saw it laying here, come out. So let's make sure we get this under control. Let's take a look at our button. Obviously goes in the hole there, and since it's got a leg here, I'm going to assume it goes back in like this. So we'll have that back in like that. And the circuit board is here, and we can already see the antenna. Here's the antenna from here to here. So you've marked antenna 1. Here's your magnetic reed relay that picks up the magnet. Of course, this is just your battery. It's going to be probably your terminal. So here's our antenna. Let's get a measurement. This section in here is about 1.2 inches. 1.2, I'll call it 1.22. This section here is about 0.7. So about 1.8, 1.75 inches long. Now what I want to do is I want to figure out what would I need. Actually, I got two things I want to do. One is I want to fire up my meter. I want to grab a couple probes, and I want to check and make sure that we're only connected one end on this antenna. So give me just a second to get a couple probes. Okay, we should have continuity set up. Let's do it this way. Coming up through here, let's go to the ground here. Our ground over here is ground for sure. We know it because it's coming right off the battery. We've got no continuity to that end of that, but I do have continuity, I'm sure, from here. From here to this end of the antenna. Absolutely. And this side of the antenna is the side that doesn't look like it's hooking to anything. I can't. Some soldering plugs left on the board, naughty them. That does not look like it connects to anything, so that's just a mount point. This side over here, on the other hand, is going to be that's going to be our mount point right there. And this side over here is our antenna, going to be our antenna, because I can see the trace coming off of here. And the trace from here runs, looks like, to this capacitor C7, which would make sense. Oh yeah, there's our, so this is our antenna. It's even marked antenna. So we're going to take this off, and we're going to figure out what wire, what size we want. So I'm going to fire up the vacuum solder sucker. That's going to take a minute to warm up, so I'll be back. Okay, so when we're waiting on our solder sucker to go ahead and grab a drill bit, the right size for the wire we're going to use as an antenna, now that I see we can and definitely do what I wanted to do. And what I've done, look over here on the, if you look at the board, this unit has one side that has the little reed relay, and the antenna runs down the opposite direction. We want to come out of here straight out of this case. So if you put it in the way it would be, it'd be to this side. So I've figured out how much space under the board I have. So the wire needs to come out about where that little dot is, you can see right there. So I'm going to drill a tiny hole for that tiny wire. Now, this wire that magically appeared was because I went online and looked up the frequency that we come up with, how long an antenna we needed. And it turned out we needed just about a foot exactly. And you do that by just going on Google antenna length calculator, and I did a half wavelength for 433.833, and it was 1 foot 0 inches. So that's what I made. So what we're going to do is I'm going to take and tie a knot right here, because that's going to be our strain relief. I made the wire just a tiny bit longer so that I could do this and still have the length that I'm looking for. And now I just got to get it back out. And that way you can't pull too hard on it. So now we're going to strip this. We've got that ready. I'm going to go ahead and warm up my regular soldering iron to get it going so that it'll be ready when the time's ready. And tin this wire. We're going to go ahead and tin this wire. So we're ready to go when the time comes for that. And with that, we're ready. See if we can desolder this. It's kind of hot. Gotta be careful you don't get back on that wire. Man, careful, I keep touching that wire. Now, question is, making any headway with it? Might be difficult to get this wire out. Keep working on her, maybe a little soldering iron action to heat it while I'm pushing might help. There we go, we got a little bit out. Now can we do it on this side? Yeah, let's see what happens. Try to get her out now. That one's out. Now can we get this one out? Yes. And that's it. We got this wire out. So the antenna's out there. Obviously, we need to attach this antenna. So it's going in here. A little too much solder on there. So let's get our wire in there for an antenna. Let's solder. Okay. There she is. Let's get her soldered in. Clip her off good here. Make sure we don't have any shorts or any problems like that. And we now have our 1/4 inch antenna. And with any luck, that knot's not too big. That could be a problem. We'll see. Question is, can I get this in now? This has to go in. This little bit needs to go in. He's got to go in this way. Like that. And now we've got to get our board back in. Without our button falling out. Like this. Trying to get it to where you can see it. It's not easy because it's hard for me to see when. But that's that. So now we want this dropped in. All right. Now maybe we're all right. Let's put our battery in. Okay, our button looks good. Now, here's the question. Let's put the antenna out that way. Let's put our magnet up here. There we go. Wow, 21. Yeah, I think we added a lot more signal. I think we added a ton more signal to this. I believe a 1 foot wire is a big difference from minus 41 to minus 21. Actually, I think it was minus, I have to go back and look at the video, but I think it was minus 42.5, I remember right. So, I mean, we're over 20 dB difference. Wow. Yeah, this should make a big difference. So, okay, hold up. At this point, I got to tell a story. Yes, you just saw me testing the sensors, and yes, we increased the signal output while the actual sensor wasn't modified as far as signal strength. Just a more efficient antenna is getting us a little more effective radiated power. So we're going to be able to, I'm going to spoil the ending, we're going to be able to fix his problem. He's definitely going to get the house. But there's a little bit of unexpected consequence that occurred. You see, this is about 8 o'clock at night that I'm doing this and testing the sensor on my bench. I live about 1/8 of a mile from my parents with buildings between us. And I finished up, and being that it wasn't that late and my dad and I are both night owls, I called him up to see if he wanted me to run down there real quickly and put his sensor back on his barn so that his alarm system would be complete and he would be protected in his garage. When he answered the phone, what I heard sounded like chaos. So my first question was, what's going on? My dad says, I don't know. We've got the alarm people on the phone. They've called the police. We've had to cancel that. I've got my, I'm running around the house. The alarm keeps going off. We don't know why. And a light bulb goes off. Not only have I extended the range a little bit to get him from his garage into the house, I've extended the range so much that I'm triggering their alarm off of my bench in the lab 1/8 of a mile away. So you got to be careful if you're doing this to a sensor on an activated alarm system, because it can cause chaos. They were pulling their hair out. The alarm company couldn't figure out what was going on. My parents couldn't. They were worried someone was trying to break in, but they couldn't find anything. Anyway, I calmed everybody down. We went down and put the sensor on. Everything's great. One question was, my father did ask, hey, with this range being extended, are we going to be setting off other alarms? And the answer is no, because these sensors get registered to the alarm by their serial numbers. No other alarm will ever pay attention to your sensor. So that's not a problem. And while 1/8 of a mile seems like a long way, that's not very far at all at 433 megahertz. It's that's a pretty low frequency signal. And even though these sensors put out a very low power, that's pretty common range for 433 equipment. We just put a little more efficient antenna on and just pushed it out there a little bit. So keep this in mind. You may be getting farther than you think when you do this. So keep an eye that you're not causing problems. So let's get back to finishing up the video. So there you go. You want to know how to modify a Simplisafe Gen 3 sensor to add an external antenna to get some more range. There you are. That's going to do it. It's going to work. You're going to get a massive amount more range with this little short little 12-inch antenna. I bet hardly over 11 3/4 inches, 11 1/2 inches actually, probably is all it's sticking out. It's easy enough to tape that across the top of your door or whatever. This will work perfect. So hope that's been helpful. Hope you learned something. Hope you can put this to use somewhere if you're like Dad and got a garage or something farther away and you need that extra distance. This is your solution. It's pretty straightforward. So thanks for tuning in. Hope you enjoyed it. Hope you got something from it. I'd appreciate it if you'd subscribe if you haven't, like if you will, hit the notify button if you want to catch other video. See you in the next one.